What is the shape of the iris dataset obtained using load iris function? A 150, 4. B 150, 3. C 150, 5. D. All of the above. True. The iris dataset has 150 samples and 4 features: sepal length, sepal width, petal length, petal width. So, if you access only the features, the shape would be 150. 4. Load iris. Used for loading iris dataset for classification tasks. If you have 150 data points and each data point has 4 features, the shape of the dataset would be 150. 4. False. The iris dataset does not have a shape of 150. 3. It has 4 features. Shape. Used to understand the dimensions of a dataset. Shape of a dataset is a tuple representing the number of rows and columns in the dataset. True. The iris dataset also includes a target variable indicating the species of Iris setosa, versicolor, virginica. This target variable adds an extra column, resulting in a shape of 150. 5. Dataset. A collection of data points used for training machine learning models. A dataset with 150 samples and 5 features including target variable would have a shape of 150. 5. True. As explained above, the iris dataset can have both shapes 150. 4 and 150. 5 depending on whether you are working with only the features or both features in the target variable. Machine learning. Used for building models that learn from data and make predictions. Machine learning algorithms often use datasets to train models and predict outcomes. D. All of the above. What kind of information does the linear dataset store? A. Information about the physical fitness of individuals. LTBRGTB. Details regarding economic indicators. LTBRGTC. Data on weather patterns. LTBRGTD. Information about astronomical events. Correct. LT font style font size 16 px quotient. The linear dataset encompasses data on individuals' physical fitness, including measurements like LT font GT. LT font style font size 16 px quotient. The linear dataset encompasses data on individuals' physical fitness, including measurements like LT font GT. Incorrect. The linear dataset does not store economic data. It focuses on physical fitness metrics. A. Information about the physical fitness of individuals. LTBRGTB. Details regarding economic indicators. LTBRGTC. Data on weather patterns. LTBRGTD. Information about astronomical events. Incorrect. The linear dataset is not related to weather patterns. It deals with physical fitness data. A. Information about the physical fitness of individuals. LTBRGTB. Details regarding economic indicators. LTBRGTC. Data on weather patterns. LTBRGTD. Information about astronomical events. Incorrect. The linear dataset is not related to astronomical events. It primarily focuses on physical fitness. A. Information about the physical fitness of individuals. LTBRGTB. Details regarding economic indicators. LTBRGTC. Data on weather patterns. LTBRGTD. Information about astronomical events. A. Information about the physical fitness of individuals. This function is used to load the linear dataset. LT font style font size 16 px EG sklearn. Datasets. Load linear UDLT font EGT. Loading datasets is a crucial step in machine learning, enabling analysis and model training. LT font style quote font size 16px quotient dataset loading LT font EGT. Predictive modeling of physical fitness based on measurements. Exploring relationships between fitness variables. Clustering individuals with similar fitness characteristics. LT font style quote font size 16px quote GT USE cases LT font GT. This module provides access to various datasets commonly used in machine learning. LT font style quote font size 14px quote EGT sklearn, dataset SLT font EGT. Preprocessing steps like cleaning, normalization, and feature engineering are often applied to datasets before training. LT font style quote font size 14px quotient data preprocessing LT font EGT. Let's assume we have the Lennard dataset with the following data for a few individuals. Individual chins, sit-ups, jumps, weight, height, age. Dash 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 dash. A10, 50, 60, 170, 17525. B15, 40, 55, 180, 18030. C8, 65, 70, 165, 17028. We can use this data to perform various analyses like regression, predict an individual's weight based on their chins, sit-ups, and jumps using linear regression. Clustering, group individuals with similar fitness characteristics using k-means clustering. Correlation, analyze the correlation between fitness variables like chins and sit-ups. What does the load sample image function in sklearn's datasets module return? A. A grayscale image as a numpy array. B. A color image as a numpy array. C. A tuple containing the image as a numpy array and its target label. D. All of the above. True. The load sample image function can return a grayscale image as a numpy array. Suitable for tasks where color is not crucial. Like image classification. Grayscale image, this function can load a grayscale image as a numpy array, which is useful for tasks like image classification where color information might not be relevant. True. It can also load a color image as a numpy array, which is essential for tasks where color is a key factor, such as object detection or image segmentation. Color image, it can also provide a color image as a numpy array, which is essential for tasks like object detection or segmentation where color is an important feature. True. The function can also return a tuple with the image and its corresponding target label. This is valuable for supervised learning where labeled data is needed. Image with target label, the function can also return a tuple containing the image and its corresponding target label. This is helpful for supervised learning tasks where you need both the image and its associated ground truth information. True. As the function can handle all these return types, the correct answer is D, all of the above. The load sample image function in sklearn datasets is designed to be versatile. It can provide you with different types of images depending on your needs. D. All of the above. sklearn datasets. This module within sklearn provides access to various datasets, including sample images, for machine learning. sklearn datasets. This module in sklearn provides access to various datasets for machine learning, including sample images. NumPy array. A NumPy array is a fundamental data structure in Python used to store and manipulate multidimensional data effectively, such as images. NumPy array. A NumPy array is a fundamental data structure in Python for storing and manipulating multidimensional data, like images. Image classification. This task involves identifying the category or class of an image. For example, recognizing a dog, cat, or car. Image classification. This involves identifying the category class of an image. Like recognizing a dog, a cat, or a car. Identifying spam emails based on their content and images. Object detection. Object detection focuses on locating and identifying specific objects within an image, such as finding people, cars, or furniture. Object detection. This task aims to locate and identify specific objects within an image, such as finding people, cars, or furniture. Autonomous driving systems identifying pedestrians and obstacles. Image segmentation. Image segmentation partitions an image into regions based on their properties, like color or texture, to create a pixel-level map of objects. Image segmentation. This technique involves partitioning an image into regions based on their properties, e.g., color, texture, creating a pixel-level map of objects. Medical imaging for tumor detection or analysis. Supervised learning. In supervised learning, a model is trained on labeled data, e.g., images with classifications to make predictions on new, unseen data. Supervised learning. This type of machine learning involves training a model on labeled data, e.g., images with their corresponding classifications to make predictions on new, unseen data. Predicting customer churn based on their past interactions and demographics. The loadSample image function returns a NumPy array representing the image. The array's dimensions depend on the image type. For a grayscale image, it's a 2D array height, width. For a color image, it's a 3D array height, width. Channels, where channels represent the color components, e.g., RGB. Imagine a 10 by 10 grayscale image. It would be represented as a 2D NumPy array of size 10, 10. A 5 by 5 color image RGB would be represented as a 3D NumPy array of size 5, 5, 3. LT font style font size 14px GT. What is the primary function of LT font? Color blue EG sklearn, datasets, loads VM light file LT font EGT in machine learning. LT font GT. LT font style font size 14px GT LTBGTA. LTBGT to load data from a file stored in SVM light format. Suitable for training support vector machine SVM models. LT font GT. LT font style font size 14px GT LTBGTB. LTBGT to create a new dataset in SVM light format for later use with SVM algorithm SLT font EGT. LT font style font size 14px GT LTBGTC. LTBGT to preprocess and normalize data for SVM. Classification. LT font GT. LT font style font size 14px GT LTBGTD. LTBGT to perform feature selection for optimal SVM model. Performance. LT font GT. True. LT font style font size 14px GT LT font. Color blue EG sklearn, datasets, loads VM light file LT font EGT is designed specifically to load data from files saved in the SVM light format. This format is commonly used in training support vector machine SVM models. LT font GT. False. This function is for loading, not creating datasets in SVM light format. False. While data in SVM light format can be used for SVM classification, this function primarily focuses on loading, not preprocessing or normalization. False. Feature selection is a separate process and not the primary function of this method. A. LT font style font size 14px GT LT font color blue SVM light format font GT a compact and efficient format for storing sparse datasets commonly used in SVM training. LT font GT. LT font style font size 14px GT LT font color blue support vector machines SVMs LT font GT. A powerful supervised learning model commonly used for classification and regression tasks. LT font GT. LT font style font size 14px GT LT font color blue sparse dataset SLT font GT datasets, where most feature values are 0, often encountered in text processing and high-dimensional data. LT font GT. LT font style font size 14px GT LT font color blue data preprocessing LT font GT. Transforming raw data into a suitable format for machine learning algorithms, often involving normalization or scaling. LT font GT. LT font style font size 14px GT LT font color blue feature selection LT font GT identifying the most relevant features for a machine learning model, improving performance and reducing complexity. LT font GT. Training SVM models on datasets stored in SVM light format. Evaluating SVM model performance on pre-existing datasets. Imagine a dataset with 10 features, but only 2 or 3 features are non-zero in each instance. This sparse nature makes the SVM light format efficient for storage and training. Using sklearn datasets, loads VM light file would allow you to read this data directly into your SVM model, which statement accurately describes the functionality of the loads VM light files function from A. sklearn datasets module. A. Loads data from a file in the libs VM format, returning both the data and target values. B. Loads data from a file in the CSV format, returning both the data and target values. C. Loads data from a file in the JSON format, returning both the data and target values. D. Loads data from a file in the ARFF format, returning both the data and target values. E. All of the above. A. Correct. The loads VM light files function is designed to handle data stored in the libs VM format, which is a common format for representing sparse data used in machine learning. Particularly for support vector machines SVMs, this function returns both the data features and target values labels from the specified file. The function is highly efficient for working with large datasets. A. Loads data from a file in the libs VM format, returning both the data and target values. Libs VM format, sparse data, support vector machines SVMs. B. Incorrect. The loads VM light files function is specifically designed for the libs VM format, not CSV format. B. Loads data from a file in the CSV format, returning both the data and target values. C. Incorrect. The loads VM light files function is specifically designed for the libs VM format, not JSON format. C. Loads data from a file in the JSON format, returning both the data and target values. D. Incorrect. The loads VM light files function is specifically designed for the libs VM format, not ARFF format. D. Loads data from a file in the ARFF format, returning both the data and target values. A. Incorrect. The loads VM light files function is designed specifically for the libs VM format, not other formats like CSV, JSON, or ARFF. E. All of the above. A format for storing sparse data used in machine learning. Particularly for SVMs, it is highly efficient in representing data with many zero values, which is common in real-world datasets. Data with many zero values, common in fields like text data, images, and sensor readings. Let's say you have a dataset of 1000 data points, each with 100 features. If most features are zero, using the LIBSVM format would be highly efficient as it only stores the non-zero values and their corresponding indices. Data where a significant portion of the values are zero. It is a common occurrence in many real-world datasets, such as text data, images, and sensor readings. Text data presence or absence of words. Images pixel values. Sensor readings zero values for inactive sensors. Consider a document with 10,000 words, representing it as a vector of 10,000 dimensions, where each dimension corresponds to a word. Will likely have many zero values as a document rarely uses all the words from a vocabulary. A powerful supervised learning algorithm used for classification and regression tasks. It aims to find the optimal hyperplane that best separates different classes in a dataset. It excels in handling high-dimensional and sparse data. Image classification, text classification, fraud detection, bioinformatics, recommender systems. Imagine classifying emails as spam or not spam. SVM would learn a hyperplane in a multi-dimensional space that separates spam emails from non-spam emails based on features like word frequencies and sender information. Which of the following are attributes of the wine dataset available using the loadWine function? From sklearn, A. Features representing chemical analysis of wines. B. Labels indicating the type of wine. C. Information on the vineyard where the wines were produced. D. All of the above. A. Features representing chemical analysis of wines. Correct. This attribute is available in the wine dataset. The loadWine function returns a dataset containing chemical analysis features of different wines. The loadWine function provides a dataset with chemical analysis features in corresponding class. Labels. But it does not include vineyard information. B. Labels indicating the type of wine. Correct. The dataset also contains labels for each wine, indicating the type of wine it belongs to. The loadWine function provides a dataset with chemical analysis features in corresponding class. Labels. But it does not include vineyard information. C. Information on the vineyard where the wines were produced. Incorrect. The loadWine function does not include information about the vineyard where the wines were produced. This information is not part of the dataset. The loadWine function provides a dataset with chemical analysis features in corresponding class. Labels. But it does not include vineyard information. D. All of the above. Correct. Options A and B are correct, while option C is incorrect. Therefore, all of the above is not correct. The loadWine function provides a dataset with chemical analysis features in corresponding class. Labels. But it does not include vineyard information. D. All of the above. The correct choice is D because options A and B are correct. Options A and B are correct because the dataset contains chemical analysis features of different wines and the corresponding class labels. The loadWine function provides a dataset with chemical analysis features in corresponding class labels, but it does not include vineyard information. So the answer is D. Sklearn datasets. Sklearn provides various built-in datasets for machine learning tasks, such as the wine dataset. These datasets facilitate exploration, prototyping, and benchmarking of algorithms. Sklearn provides various built-in datasets for machine learning tasks, such as the wine dataset. Exploring the wine dataset using the load_wine function. You can access the wine dataset, which contains features like alcohol content, malic acid, and others, along with corresponding class labels for the 3 types of wine. Prototyping classification models. You can use this dataset to quickly prototype classification models to predict the type of wine based on its chemical composition. Benchmarking algorithms. You can compare the performance of different classification algorithms on the wine dataset to evaluate their effectiveness. Imagine you have a dataset with 100 wine samples, each with 13 features, e.g., alcohol content, malic acid, ash, etc. You can use this dataset to train a classification model to predict the type of wine for each sample. Data attributes. The load_wine function returns a dictionary-like object containing various attributes like DESCR, feature names, and target names. These attributes provide valuable information about the dataset structure and content. The load_wine function returns a dictionary-like object containing various attributes. Understanding dataset description. The DESCR attribute gives a detailed description of the dataset, including its origin, purpose, and the meaning of each feature. This helps you grasp the context of the data. Identifying relevant features. The feature names attribute lists the names of all features, e.g., alcohol, malic acid in the dataset. This is essential for data analysis and feature selection. Understanding target classes. The target names attribute lists the names of the target classes, e.g., class 0, class 1, class 2 for different wine types. This information is crucial for evaluating classification models. For the wine dataset, you might have features like alcohol, malic acid, ash, etc. represented as feature names: alcohol, malic acid, ash. This tells you what variables are included in the dataset for each wine sample. Dataset structure. The wine dataset typically consists of 2 parts: data and target. The data part contains the chemical analysis features for each wine sample, while the target part contains the class labels corresponding to each sample. This structure facilitates building models that learn the relationship between features and class labels. The wine dataset typically consists of 2 parts. Training classification models. You can use the data as input to train a classification model to predict the target wine type for new wine samples. Evaluating model performance. Once you have trained a model, you can test it on unseen data to assess its accuracy in predicting wine types based on chemical features. If you have 100 wine samples, the data might be a matrix with 100 rows samples and 13 columns features. The target would be a 1D array with 100 elements, representing the class label for each sample, e.g., 0 for class 0, 1 for class 1, etc. Which of the following statements accurately describes the purpose of sklearn datasets? Make biclusters. A. Generates data with a predefined biclustering structure, ideal for testing biclustering algorithms. B. Performs biclustering on existing datasets, identifying hidden patterns within rows and columns. C. Evaluates the performance of biclustering algorithms using predefined metrics. D. All of the above. A. Generates data with a predefined biclustering structure, ideal for testing biclustering algorithms. Correct. The make biclusters function allows you to generate synthetic datasets with a predefined biclustering structure. This is highly useful for testing and evaluating biclustering algorithms, as you have a known ground truth to compare against. B. Performs biclustering on existing datasets, identifying hidden patterns within rows and columns. Correct. The make byclusters function can also be used to perform byclustering on existing datasets. It utilizes algorithms like the checkerboard byclustering algorithm to identify hidden patterns within rows and columns, revealing relationships that might not be apparent through traditional clustering. C. Evaluates the performance of byclustering algorithms using predefined metrics. Correct. The make byclusters function provides functionality for evaluating the performance of different byclustering algorithms. It can assess the accuracy and stability of these algorithms using various metrics, helping you choose the most appropriate one for your specific analysis. D. All of the above. Correct. The make byclusters function is a multifaceted tool that encompasses all the capabilities mentioned in options A, B, and C. It is designed to generate synthetic datasets with known byclustering patterns, perform byclustering analysis on existing data, and evaluate the performance of different byclustering algorithms. D. All of the above. Byclustering, a technique that simultaneously clusters rows and columns of a data matrix, revealing patterns that are not visible in traditional clustering methods. Gene expression analysis, where byclustering can identify groups of genes that are co-regulated under specific conditions. Synthetic data generation, creating artificial datasets with known properties for testing and evaluating algorithms. Benchmarking and comparing different byclustering algorithms on data with known ground truth. Byclustering algorithm evaluation, assessing the performance of byclustering algorithms using metrics like accuracy and stability. Selecting the most appropriate byclustering algorithm for a specific data analysis task. Make byclusters function, a built-in function in sklearn for generating synthetic data with byclustering patterns, performing byclustering analysis, and evaluating algorithms. Imagine you are working with gene expression data from a study of different cancer cell lines. You have a matrix where rows represent genes, columns represent cell lines, and values represent gene expression levels. You want to identify groups of genes that are co-regulated in specific cell lines. By applying the make byclusters function, you could potentially uncover clusters of genes that are upregulated in certain cancer types and downregulated in others, providing valuable insights into the molecular mechanisms of cancer. Gene 1, Gene 2, Gene 3, Gene 4, Gene 5. Cell line A, cell line B, cell line C, cell line D, 10, 5, 2, 8, 4, 7, 9, 1, 6, 3, 1, 5, 2, 9, 4, 6, 7, 1, 8, 3,